All right. All right, folks, I hope this works. Make sure I'm not muted. Okay. All right. This is the coach assessment for our final last ditch effort to prepare for the Algebra 1 and of course exam. All right. This is the assessment from the coach book, and there are 50 questions total. All right. And we're going to press through and knock this out as quickly as possible. All right. Number 1, solve x plus 21 equals 7. Y'all, this is super simple. We're just going to subtract 21 from both sides. Okay, and that's going to give us, what is 7 minus 21? That's going to give us a negative 14. All right. Number 2. All right, assume f of x equals g of x. All right, so I have a function f set equal to function g. Oh, I guess I could record it. I wonder if I shared my screen, could I do both? Let me see. Screen. If I can record it in both locations. Hold on, y'all. Okay. All right, this is going to be interesting. And I'm going to record on Teams as well. I don't think I can do that. Yeah, it's not going to let me do it. All right, stop share. Stop record. I tried, y'all. Okay, number 2. Assume function f is equal to function g. And the question on the floor is, which of the following pairs of functions may be used to represent the function 3x equals x minus 4? 3x equals x minus 4. All right, so we have f of x equals g of x. And we have 3x is equal to x minus 4. Young people, what is in the position of f of x? Okay, 3x. So I would venture to say that f of x is equal to 3x. And what value is in the same position as g of x? Well, that's x minus 4. So I would venture to say that g of x is equal to x minus 4. Okay, so the best answer in this situation will be answer choice A. Okay, answer choice A. All right, number 3. All right, which of the following is equivalent to 3 times the square root of 20 plus 2 times the square root of 72? Young people, I can't combine these radicals until the radicands are exactly the same. So what I'm going to do is I'm going to simplify both of these radicals, okay? And I'm going to take the radicand and I'm going to do prime factorization to see what the greatest, see if there's a common, we're going to do prime factorization, see what the biggest perfect square factor or the greatest perfect square factor is, to see if we can get on some sort of common ground. We may not be able to combine them at all, but we'll see once we do the prime factorization. So with 3 root 20, okay, I'm going to take 20. I'm going to rewrite it over here. Oh my gosh. Let me just leave well enough alone. All right, so we have 20. Okay, So I'm taking the radicand 20. I'm doing prime factorization. We know that this is going to be 5 times 4, right? Some of you all know that you can stop here, all right? And you know that the square root of 4 is 2, all right? But some of us can't. And I'm going to break this down a little bit further into 2 times 2. So I can rewrite 3 root 20 as 3 times the square root of 2 times 2 times 5. All of these values are prime numbers. And I'm looking for pairs. Remember, 2 times 2 is 4, and the square root of 4 is 2. Cross out the pair, pull out the 2. Okay, so this is equal to 6 root 5. Okay, all right, cool. So 3 root 20, I can replace that with 6 root 5. All right, so now let's do 2 root 72. And I'm going to take 72, and we're going to do prime factorization. All right, so I have 8 times 9 is the most obvious factors, are the most obvious factors of 72. And then I'm going to take 8, 2 times 4. All right, and 9, of course, is 3 times 3. I can break down that 4 one more time. And I have 2 times 2. All right, cool. So now I can rewrite 2 root 72 as 2 times the square root of, where are my prime factors? 2 times 2 times 2. 2 times 2 times 2 times 3 times 3. All right. Now I'm looking for pairs. Here are a pair of 2s. 2 times 2 is 4. The square root of 4 is 2. Here are a pair of 3s. Okay. 3 times 3 is 9. The square root of 9 is 3. And let's multiply these together. 3 times 2 is 6 times 2 is 12. So now I have 12 root, what's left? 12 root 2. All right. So this is going to be plus 12 root 2. Well, I can't combine them because the radicads aren't the same, but I have simplified them. So that means that the best answer, okay, the best answer is going to be 6 root 5 plus 12 root 2. Please keep in mind that you cannot add radicals that do not have the same radicand. All right. Number 4. All right, so we have a word problem. It says the president of a community college hopes to increase the school's enrollment each year, okay? And it hopes to improve the school's enrollment each year. The number of students enrolled at the school during the year when the president began this initiative was 4,000. So the initial population, student population was 4,000. She listed the approximate number of students she hopes to have enrolled each year in the table below. So the question on the floor is, which is the closest to the rate of increase that the president of the school hopes to have each year? Well, all right. So the first thing I'm going to do is I'm going to see what the difference is between 4,000 and 4,040. Obviously, 4,040 minus 4,000 is 40, right? So we went up by 40. But what would be that percentage of increase? Well, very simply, young people, I'm going to take 40 and I'm going to divide it by 4,000. And whatever I get, I'm going to multiply it by 100 because that will give me my percentage. Okay, so let me get my calculator. I guess I can use my desktop calculator. There it is. Please move this window away. What? From the shared. Okay. All right. So we're going to say 4 divided by 4,000. Hello. Oh, number locked. Hold on. 4 divided by 4,000 equals times 100 equals, bam, 0. That doesn't seem, hold on. Right, Tyler, I'm recording. And I remember when I tried to, share both on Teams and Zoom. All right, I'm doing it on Zoom. You're not going to be able to see until I'm fully done. And I'm not teaching, I'm just recording. Unfortunately, I tried. So while I'm doing this, you can mute me out and you can continue watching your ed puzzles, and I'm going to upload it onto YouTube momentarily, okay? My apologies. All right, let me use my calculator. 40, what did I say? 4 divided by 4,000? All right, 40 divided by 4,000 equals, okay, times 100 equals, boom, I got a 1. So that means my answer, young people, is gonna be 1%, okay? Gonna be 1%. Thank you, Josiah. Thank you. I think I typed a 4 instead of a 40 initially. Something looked wrong. Okay. All right. Yeah, I wish there was a way that I could project what I'm doing, but I apologize. You can hear me, but you can't see what I'm doing. All right, number 5. Which of the following polynomials is written in standard form? Remember, young people, standard form of a polynomial is when your coefficients, your exponents are in descending order, and your exponents are no smaller than 1, okay? And so I'm looking here. This is not in descending order, it's in ascending order, so I know that A is not the answer. All right, so I have an exponent of 3, then an exponent of 1, and then an exponent of 5. That's all jumbled out of order. I have a 4, I have a 3, and then technically if there's no variable there, the exponent is 0. So this looks great as an answer. And then D, I have a 2 as an exponent, have another 2 down here. Everything's just all mixed up, so I know that that is not the answer. C is the correct answer for a polynomial that is written in standard form. All right. Uh-oh. All right, so for number 6, it says the Fish and Wildlife Department recorded the number of boats that passed a point on the river each day for 2 weeks. All right, so here are all the numbers here. Okay, number of boats that passed a point on the river each day for 2 weeks. Now the data is listed here. All right. Now, in order to compile the data into a box plot, the staff determined the lower quartile to be 11. Okay, lower quartile was 11. The median was 13 and the upper quartile was 18. Okay, so where are these values represented, young people? You see this box? This first line would be your lower quartile, upper quartile, and median. Let me write them. Lower, upper, and the median. Okay, so I'm looking for a line that sits at 11. I'm looking at a line that sits at 18. This one sits at 22 for the upper quartile. Look, upper quartile is 18, lower quartile is 11, and the median is at 13. So at the very least, this middle line has to be 13. Let's just look at the medians. If that median is not at 13, it can't be the answer. This one's at 13. Okay, this is a contender. All right, I'm going to circle that one. 13, I'm going to circle that one. This one is not at 13. Can't be it. So now I'm looking for the lower quartile to be at 11. All right, this lower quartile is at 12. That can't be the answer. So let's see if C checks out, pans out all the way, okay? Lower quartile is 11, check. Median is at 13, we already know that. And the upper quartile is at 18, yes. C pans out, okay? C pans out. Let's keep going, number 7. All right, number 7 says, a baker wants to know if she has enough flour to make 50 loaves of bread. Okay, 50 loaves of bread. Now, which of the following unit rates does she need to consider? Well, 50 loaves of bread, enough flour. All right, so we got to look at these units of measurement. All right, so let's look at answer choice D. Customers per loaf of bread. She's not necessarily concerned with how many people are about to buy this bread. We don't know why she's making the bread. Doesn't matter, okay? She's not looking for customers. Customers is not going to help her determine how much flour she's going to need to bake 50 loaves of bread. It's irrelevant information. And to D. So C, minutes per cup of flour? Minutes? I mean, I guess if you wanted to find out how long it takes to pour out a 50-pound bag of flour, this may be useful, but it has nothing to do with how many cups of flour she's going to need to bake the loaves of bread. All right? Cups of flour per minute? What? It just, for the same reason as C, just simply doesn't make sense. However, cups of flour per loaf of bread. You need to know how many cups of flour per one loaf. And then if she's making 50, she can just simply multiply those two values to find out how much total flour she needs. So obviously A is the right answer. Moving on to number 8. All right, so it says the solution to a system of linear inequalities is graphed below. Young people, you all will not be required to do linear inequalities, all right? But I'm still gonna press through and give you this information for your own edification. Now, here I see a solid line that has been shaded up in this region, and I see a dotted line that has been shaded going this region. So this is the area where they overlap. All right, so the question on the floor is, does the point -2, -3 represent a solution to the system of inequalities? Well, young people, the solution is simply gonna be where these two regions, where these two shaded regions overlap, and that's gonna be in this area here. Now, where is -2, -3? I don't know, let me change the color so we can see where it is. All right, so ooh, this is so small. Okay, -2, -3. Ooh, it looks like it's right there on the line. I think that's -3. All right, so you see how it's on that solid line? Right smack dab on the solid line? That means it's part of the solution set, because anything on the line or in this region is a part of the solution set. All right, so that would be answer choice. Let's see, it says the point is on a solid line bordering the darker shaded region. So it's the solution to the system of inequalities, yeah. Look at B, it says the point is on a solid line bordering the darker shaded. So it's not, that's not true. The point is on a dotted, no, it's not on a dotted line. The point is on a dotted line, nope, that's not true. The only answer that's true is A. Moving on. Changing my color tool. Okay. Number 9. All right, it says a marine biologist tracked the growth of a population of sea urchins along a coast. Okay, sea urchins. All right. She noted an exponential growth pattern of the population. In modeling the total population, P equals F of T over time. Okay, the population is a function of time, all right? So as time grows or time increases, the population grows exponentially. So which of the following should she use as a practical domain? What could she use as a practical domain? Well, the domain is going to be any t values, because remember, population is dependent on how much time passes. And we know that the dependent variable is going to be the y, and the independent variable, which is time, is going to be the x variable. All right. So let's see. Time has to start somewhere, right? So, and we just realized that the only two answers could be, can only be C or D, because we're talking about T as our independent variable, all right? We very simply, we can't use all real numbers because time can't be negative. P is the dependent variable, not the independent variable. So which of these do we choose? T is greater than 0 or T is greater than or equal to 0? This is a typo, bless it. All right, so time has, there's a such thing as an initial starting point or before you start tracking growth, all right? So time can be equal to 0 because the moment right before you start the clock, as soon as you touch the clock, there's a point of 0 and then it starts, right? So the best answer in this situation would be D, okay? Would be D. Just a little bit of thinking on that one. All right, number 10. Oh. All right. So it says the function f of x equals 3x minus 7 is graphed below. All right, cool. There's my y-intercept of -7, okay? And then my slope of up 3 over 1. Up 3 over 1. Up 3 over 1, and so on and so forth. Now it says, what change would be seen if f of x plus 2 were graphed? Well, young people, we talked about this. You all should know that there will be a shift upward of 2 units. So you would take this function, okay, and add 2 to it, so it would shift the function up. So instead of crossing at -7, it would cross at -5. But the slope would be the exact same. Up 3 over 1. Kind of tight there. Up 3 over 1, and so on and so forth, right? Now, we already said the answer. It says the line would shift to the right. No, we didn't say nothing about to the right. You remember when that number is on the outside of the parentheses, away from the x, it's going to be a vertical shift up or down. B says the line would shift to the left 2 units. No, it's +2. The line will shift up 2 units. Yes. D, the line would shift down 2 units. No, if it said -2, that's when it would shift down. All right, no to D. All right, moving on. Number 11. Yes, quickly. All right, number 11, it says each of the following graphs illustrates the quadratic function of the form y equals ax squared plus bx plus c. Which graph represents a quadratic function that has the coefficients that satisfy the following conditions? Okay, it says, okay, b squared minus 4ac is equal to 0. Young people, we talked about this, and this value, young people, remember, is called the determinant. We talked about I'm running out of room. But we talked about the determinant. Gotta sound it out, bless the teacher. The determinant, okay, we talked about this. And we talked about when the determinant is greater than 0, you have two roots. Okay, 2 x-intercepts. When it is less than 0, there are no roots. It doesn't cross it at all. But when it's exactly equal to 0, when the determinant is equal to 0, it only has one solution. Okay, it only has one solution. So that means it just kisses it in one point, right? So that means C is out because it doesn't even cross the x-axis, and B is out because there are 2 roots, right? All right, so we narrowed it down to A and D. Well, they give us some more information. They said that negative B over 2A, okay, is not equal to 0. All right, so that value represents my axis of symmetry, right? Axis of symmetry. And they're telling me it's not 0. Well, look at this one. Here's my axis of symmetry right here, right? Going straight down. I can't really see the purples. Smack dab. That's a vertical line going through 0 if I ever seen one. So that means it can't be that one, can it? Because this axis of symmetry is certainly not 0. It's going through what x value? X equals -5, which is not 0. Okay, so the answer choice has to be A. Has to be A. All right, let us move on. right, number 12. Can somebody type in the chat what time, or like how much time I have? What time the second period is today? All right, number 12. It says a system of linear equations and its graphs are shown below. So here are the equations, here's the graph. It says, what is the solution of the system of linear equations? Young people, this is the easiest problem in the world. The solution to a regular system of equations, not inequalities, but equations, is very simply where they cross each other, where they intersect, babies. We're not gonna make this hard. What is that coordinate? Let's see, that's a -3 and 8. Boom, answer choice D. We're not gonna make it hard, are we, y'all? Keep it moving. All right, number 13. It says Pablo is growing a tomato plant for his neighbor. All right, tomato plant for his neighbor. The tomato plant has 2 tomatoes, 106. Ugh, I don't think I'm gonna finish with this. I'll just continue in third period. I'll press pause on the recording. Y'all, I'll make sure I upload it after school at some point. I'll put a message in the chat, okay? All right, the tomato plant has 2 tomatoes. Pablo said that he expects the number of tomatoes to triple each month, okay? Triple each month, and he started out with 2. That's the initial value. I want y'all to keep in mind about the formula for exponential situations. Y is equal to, I want to say A times B to the n. Can't remember the variables, okay? Can't remember the variables, but you all will get the idea momentarily. Okay, so A would represent the initial value of the situation. So what did Pablo start off with? Well, he started off with 2 tomatoes, right? And what is going to be the growth of these tomatoes after each month? Well, that's going to be determined. That value is going to represent our base, which is going to be 3 raised to the x power, and x represents the months that passed, or m in this case. All right. So it says, after a certain number of months, he expects there to be 54 tomatoes. So after this happens, 2 times 3 to the m power, however many months gonna pass, he wants that value to be equal to 54. He expects there to be 54 tomatoes. If m represents the number of months, which equation could Pablo's neighbor use to determine when Pablo expects there to be 54 tomatoes? Young people, we made it already. We don't even have to think about it. It's already created. Boom. Answer choice C. Okay. 2 represents those first 2 tomatoes that Pablo started off with. 3 is the growth rate, all right, from month to month. And 54 is the total number of tomatoes that Pablo expects, okay, after a certain number of months have passed. All right, number 14. All right, so it says an exponential function is graphed below. Which ordered pair represents a solution to the function? A solution to the function. Well, young people, what is a solution? Young people, a solution would be any point that actually sits on the curve. Okay, that actually sits on these curves. So let's see where these points are located. We got 2, 0, over 2, up 0. That's that one right there. Boom. Over 2, up 0. Over 2, up 8. Over 2, up 8. Bam. Over 1, up 2. All right, that's there. And over 0, up 1. That's here. Well, young people, look. The only one that touched the actual curve itself was over 2, up 8. So that is the one that has to be the answer. That is the solution of a function. Any value that lands on the actual curve itself, okay? Let's go to number 15. A sandwich shop owner counted the number and type of sandwiches sold over the course of a weekend and compiled the data into the relative frequency table below. Okay, relative frequency. All right, Saturday, Sunday, okay, cool. It says if the sandwich shop sold 150 sandwiches during the weekend, all right, Which of the following statements is true? All right, so they sold a total of 150 sandwiches. Let me get my color back together. It's orange. All right. All right, so it says okay, so a total of 150 sandwiches were sold during the weekend. Which of the following is true? Well, if you look at these totals, right? 12, 0.12 for chicken. You had a total of 0.31 for turkey, 0.23 for roast beef, and 0.34 for veggie. All of these values, if you add them up, it should add up to be that 1, which represents 100%. And 100%, young people, is the full 150 sandwiches, okay? Now, about 47 of the sandwiches were made of turkey. Well, let's see. If I took 31% of 150, if I took 150 and multiplied it by 0, I'll do it on the calculator here. If I took 150 and multiplied it by 0.31, boom, 46.5. Doggone it, the first answer we see is the actual right answer. Okay, if we kept going, about 80 sandwiches were sold on Sunday. Let's see, where's Sunday? That's 0.47 of the total, right? So I'm gonna say 150 times 0.47. Nope, they said about 80. 70.5 is way far from 80, okay? And then let's see, C says about 51 sandwiches were made of roast beef. Well, let's see, that's 0.23 total for roast beef. 150 times 0.23, that ain't 50. Okay, and then 71 of the sandwiches were sold on Saturday. Where's Saturday? 0.53, let's see, 150 times 0.53. Oh. How much they say, 71? Nope, that ain't it, okay? All of those situations are wrong, okay? Everything is wrong. All right, so there we are. So the answer has to be A, because nope, nope, and nope. None of those numbers worked out. We simply took 150. Oh, bless the teacher. We simply took 150 and multiplied it by 0.31, and that gave us approximately, let me do my squiggly equal signs, approximately 47. It was 46.5, right? But if we're rounding up, let me try to cover that up. If we're rounding up, it would be 47. Okay. All right. I know it's weird to hear me talking and not see me. Y'all should be watching. I hope y'all watching them Ed Puzzle videos. Is that what you're doing? All right, y'all. All right. You'll be sorry. Number 16. A fundraiser is being held to support a local nonprofit organization. Okay. Admission costs $10 and each raffle ticket costs $3. There are no other possible costs. All right, admission ticket and then a raffle ticket. If an event goer pays the admission fee and buys X number of tickets, what type of function should be used to model the total amount spent by the event goer? Well, we know that no matter what, to get in the door, so let's say E for event, right? Total cost per event. To get in the door, I gotta pay $10, right? And if I want to participate in the 50-50 raffle, it all depends on what, depends on how many tickets I want to buy. And each raffle ticket costs $3. The event is going to cost me at least $10 and however many raffle tickets I buy. If I buy 0 raffle tickets, plug in 0 for R, 3 times 0 is 0. I'm just going to spend my $10 to get in the door, right? Well, young people, what type of function does this look like? It looks like a linear function to me. If I replace the E with a Y and the R with an X, okay, doesn't that take on the Y equal MX plus B format? Okay. a linear equation in slope-intercept form. Remember, exponential functions would be some value like 3 raised to the x power. Your exponent, your variable or your exponent would be a variable, okay? All right. Cannot be determined. There's plenty of information to make that determination. All right, moving on, number 17. Oh, bless the teacher. All right, a researcher studied the effects of changes in air temperature on home electricity usage around the country. Okay. The researcher constructed a scatter plot with her data and determined a line of best fit. The correlation coefficient was found to be 0.683. Which of the following conclusions could the researcher make from her data? Well, young people, the correlation coefficient R is 0.683. And let me just tell you this. When the closer your correlation coefficient is to a positive one, okay? That's a positive, a strong positive, like a perfectly strong positive correlation. Like a perfect, like all of the dots would line up in a perfect straight line, okay? But 0.683, since it's positive, you're gonna have a line of best fit that does that, but your dots are gonna be they're gonna be close to it, but they're not gonna be like right smack dab on it. You just kind of see a cluster of points moving upward, right? But a strong positive, if it's gonna be 1, if R is less than or equal to 1, well, I'm not gonna put the inequality there. I'm just gonna say this, the closer your correlation coefficient is to 1, the stronger your data is, okay? So she found that she found that her correlation coefficient was 0.683. All right, and she was measuring, what was she measuring again? The effects of changes in the air temperature on home electricity around the country. Okay, so what does this value mean is the question on the floor. Which of the following conclusions could the researcher make about the data or from the data? As the air temperature increases, home electricity uses increase. Okay. Okay. That seems like a good correlation to make. Let's circle that one and come back. B. And remember, we have a positive correlation, 0.68. It's not perfect, but there is enough data there. It's strong enough. It's more than 0.5. It's showing that there's some sort of correlation, right? So B says, as the air temperature increases, home electricity usage does not change. What does your mama do when it gets hot outside? I know it don't change. She just don't sit there and just look at the thermostat and not do anything, right? As the air temperature increases, home electricity usage increases, then decreases? What? That doesn't make sense. The hotter it gets, the more people use their air conditioning, right? All right, so as the air temperature increases, home electricity usage decreases. That's not true, because we all know that when you run that air conditioning, okay, your power bill is gonna go up higher, right? So nope. The best answer in this situation, young people, is as the air temperature increases, home electricity usage increases as well, because all of the dots are going up, okay? Now, if there was a negative, say this was negative 0.63, that would tell me something totally different. That would tell me as air temperature increases, home electricity usage would decrease, okay? There will be an opposite effect of the situation, all right? Let us proceed, let us move on. Number 18. All right, so a reservoir collects rainwater that is eventually filtered to provide drinking water for a local town. A town official determined that the reservoir currently holds 500,000 gallons of water. All right. If the town uses 10,000 gallons of water each day and there is no rain to replenish the water, how much water will be in the reservoir after 20 days? Well, let's think about this. They're using 10,000 gallons per day, right? They want to know what's left after 20 days. Well, how much water are they going to use after 20 days? That's going to be 10,000 times 20. How much water have they used? Well, I don't know. Let's see, what's 10,000 times 20? Let's see. Okay, I got 200,000. And then I'm going to take my 500,000 and subtract from it 200,000. And what is that going to be? You guessed it, 300,000 gallons will be left in the town reservoir. All right, let's move on. Number 19. Trying to be halfway done before the bell rings. Okay. Maybe I'll do a part 1 and part, that's what I'll do, a part 1 and part 2. Yeah. Number 19. The following system of equations is graphed below. So I got a parabola and I got a line, right? Okay. Here's my parabola. Oops. What am I doing? Here's my parabola. Here's my line. All right. And the parabola has the equation x squared plus 2x minus 3. And the line has y equals 1 minus x. Cool. It says, what is the solution set for this system of equations? Remember, young people, a system is where the two things or the two entities intersect. Where do these two values intersect? Let me change my color. Bam. And bam. What are the coordinates of those 2 points? That's where the two systems intersect, right? So I see a -4 up 5, -4 5, and I see a over 1 up 0. Bam, that would be answer choice D. Okay, we're not gonna make this hard, y'all. Oh no, indeed. No, indeed. Let's keep it going. Number 20. Oh, doggone it. All right, it says, Andrea has taken enough courses at her college to earn 100 credits toward her graduation. Cool. She needs at least 160 credits to graduate. She receives 4 credits per course. Which number of courses will give her exactly enough credits to graduate at the end of the year? Now, y'all, it says she's already taken 100, right? So how many credits does she have left to graduate? Well, 160 minus 100 would give you 60, obviously, right? And if each credit has if each course, if she can earn 4 credits per course, right? 4 credits per course, I would simply take this 60 and divide it by 4, okay? Young people, 60 divided by 4 is 15, right? It is 15. So the answer here would be 15. Answer choice A. Moving on. 21. All right, so it says the graph below shows a scatter plot and its line of best fit. Young people, this would be a good representation of that previous problem we did that had a correlation coefficient of 0.683 or whatever it was, okay? Now it says which represents the equation of the line of best fit and the best prediction of the value of y when x is equal to 15. Well, first we got to figure out our line of best fit because it only goes to 10, right? And I got to figure out what happens out here when this goes to 15. What is the value of x? What is this value right here? Okay, I'm sorry, not what is the value of x, but what is the value of, come on. What is the value of the function when x is 15? I did not mean to put that there. I just put a big old juicy dot. Okay. All right, so first thing I'm looking for is my y-intercept. My y-intercept is 4. Okay, cool. And I'm looking for a slope. Up 1, 1 over 3. Okay. Up 1 over 3. Okay. So young people, if I got my y-intercept, if I got a slope, we're not gonna make this hard. I know what my equation is. It's gonna be y. Well, remember, y equals mx plus b is my template, right? Slope-intercept form. My y-intercept is 4. It's crossing the y-axis at 4. My slope I just found is going to be 1 over 3. So I'm going to put in 1 over 3 here for m. So I have 1 over 3x plus b. Y equals 1 over 3x plus b. On the strength of my equation, I'm going to eliminate c and d because they have the wrong slope. Cool. Now, they want me to figure out what's going to be the value of my function when x is equal to 15. Well, guess what I'm going to do? I'm going to plug in 15 for x. So I have y equals 1 over 3 times 15 plus 4. 15 divided by 3 is 5. 5 plus 4 is 9. So the answer would be A. What number is this? 21? 21. All right. Number 22. All right, it says a teacher is correcting a student's homework assignment, but she cannot read one line of the student's work. With the student's work is shown below, with a blank space representing the missing line. Okay. Which of the following represents the correct step 4 and the property that would be used to justify the step? All right. Well, let's see what's going on. All right, we got this equation. Negative 2x plus 11 equals negative 5. All right. Looks like they subtracted 11 on both sides. That's what you see here, minus 11, minus 11. All right, that's a subtraction property of equality. Cool. So now we're left with, all right, this becomes 0. And you're left with negative 2x is equal to negative 16. So what would I do to get from this step to this step? What's the halfway point? Well, you all know that I'm going to have to divide by negative 2 on both sides. Okay, and young people, very simply, if you divide on the same side, or wait, I'm sorry, if you divide by the same value on both sides of the equal sign, very simply, young people, that is the division property of equality. Okay, and that is going to give us answer choice B. Answer choice B. We're moving on, number 23. I think I'm gonna make my deadline, y'all. I'm trying to get number 25 at least. Trying to get number 25, y'all. All right, 23. Which of the following, which represents the fully factored form of the following polynomial expression? Young people, you're not gonna have to do a problem like this, but we're gonna thug it out and push through, and we're gonna do this. All right, so I have 16x to the 4th power minus 1 over 81. All right, so I see a bunch of, not a bunch, but I see some perfect squares, and I'm subtracting 2 perfect square situations. So I know the difference of squares says a squared minus b squared is equal to a plus b times a minus b. So young people, when I split this up, this is going to be 4. The square root of 16 is 4, right? 4x squared, because half of 4 is 2. Got my 4x squared over here, right? 1 over 81 is equal to 1 over 9 times 1 over 9. The square root of 81 is 9, right? So I have 1 over 9 here, 1 over 9 here, plus and minus, all right? So there's no such thing as addition of squares. So this is gonna stay, all right? So anything that has 4x squared plus 1 over 9, I'm keeping as my answer. That's not my answer. That's not my answer, okay? So it's between either A or D. Well, young people, look at this one right here. I can further simplify the situation. This is another situation of difference of squares. The square root of 4x squared is very simply going to be 2x. So I have 2x and 2x. And 1 over 9 is equal to 1 over 3 times 1 over 3. So I'm going to put my 1 over 3 here. And my 1 over 3 here. Plus 3 minus 3. Bam. What's the answer? I got, and bring this down, shimmy on down, 4x squared plus 1 over 9. And bam, D is my answer. Okay, again, 24. All right, given the function f of x equals 2 times 4 to the x power minus 5, what is the value of f of 2? Young people, all you got to do is wherever you see an x, you're going to plug in a 2. So we're going to say f of 2 equals 2 times 4 to the 2 power. Sorry, I try to do parentheses and then I don't know. My brain is tripping. Let me drink some water. And y'all, we're going to follow order of operations. Please excuse my dear auntie Chantrice. All right. So we're going to say 2 times 16 minus 5. Okay. Handle your exponents first. Now we're going to handle our multiplication. So I have 32 minus 5. And 32 minus 5, I don't know what 32 minus 5 is. What is it? 27? Yeah, that's what it is. Answer choice B for 24. I think y'all know I don't know how to add. All right, number 25. Ooh. I might make it a 26. All right, so 25 says statistics were kept. Ooh, that word is hard to say sometimes. Statistics were kept for the 2 baseball pitchers, Lord have mercy, Greg and Tom, throughout the season. The histograms below show the number of runs allowed per game by each pitcher. All right, so it says, which statement below is true about the performances of the 2 pitchers? I don't know nothing about no baseball. Doggone it. Let's read. Let's see. It says the mean of Greg's runs allowed is a better indicator of typical pitching performance than the mean of Tom's runs. Well, let's look at Greg's runs. So we had 5 people. I'm sorry, wait. He allowed 1 run 5 times. He allowed 2 to 3 or 0 to 1 5 times. So this is every game. Okay. He allowed 2 to 3 runs 6 times. He allowed 4 to 5 runs 3 times, and he allowed 6 to 7 runs once. So if I had to look at this person's data, his median or mean, the average on average, you see how it kind of skews up? It kind of follows this skewed pattern, like it starts high and then it kind of tapers down, right? Okay. So most of his data, his mean is going to fall in this region, over in this area. All right. But Tom's information is kind of all over the place. Okay. It's not a very good indicator, which is why they're saying typical pitching performance than the mean of Tom's runs. Tom's runs are all over the place. All over the place. There is no pattern to his runs. Now look at B. It says the range of runs allowed by Greg is greater than the range of runs allowed by Tom. Is that true? What's the range? Highest is 7, lowest is 0. 7 minus 0 is 7. Highest here is 11. Lowest here is 0. 11 minus 0 is 11. So the range goes from 0 to 11. So it says the range of Greg is greater than. No, that's not true. The range of Tom's is greater than. The median of Greg's runs allowed is greater than the median of Tom's runs allowed. No, that's not true either. The mean of Greg's runs allowed is greater than the median. The mean of Greg's runs allowed is greater than the median of Tom's runs allowed. That is not true either. The best answer in this case, young people, is answer choice A. All right, the mean of Greg's runs allowed is a better indicator of a typical pitching performance than the mean of Tom's runs allowed. Okay, all right. Number 26. All right, so it says the table below represents ordered pairs of a function. Oh, the bell's about to ring. I made my goal though, y'all, right? I'm gonna press pause here. Part one, I'm gonna stop the video. Hold on, let me stop sharing. Let me stop the recording.